All righty. So, you guys have any questions from last time? We've been working on these rational function problems. I think at this point we finally assigned some of them that we should be able to do. Anybody got questions? No questions? That's okay. All right. I get it. It's Irish week. Nobody's done anything. Well, let's continue on. We'll do a little bit more in section 14.1. It'll be our last day there. And then we'll call her quits for today. So, at this point, we've talked about how to find all the attributes for a rational function. We're now going to talk about how to decide, or how to take those attributes and do a little bit more and generate a graph out of this. Sound good? Yes, Mr. Kulik, sounds great. Oh, good. I'm glad you're so excited. Okay. So the first thing I'm going to do is, what are the attributes I need to find? I need to find vertical asymptotes, removable discontinuities, x-intercepts, y-intercept, and then my horizontal or slant asymptote situation, right? Those are the 5 things I need before I before I can start figuring out what my graph looks like. Who remembers how to do any of these? What do we need to do? Who remembers one of these on how to do it, how to find it? Ryan. Which one are we looking for right now? Okay. Yeah, so to find the vertical asymptote, we'll start by factoring the denominator. Hopefully you see that factors to x minus 2x plus 2. Great. What do we do after we factored the denominator? Good. You set the denominator equal to 0. If we apply the zero product property, we get 2 solutions of 2 and negative 2. And I guess we buzzed right through something here. What did we buzz through that I didn't make mention of? That we should have really checked before we set that denominator equal to 0? Should check to see if I can reduce, right? Clearly we couldn't. I didn't say that though. Important that we make sure that we're checking that. So we have 2 vertical asymptotes at 2 and negative 2. So far, so good? Great. Because there was no reducing that we could do, what did that tell me about the removable discontinuities? None. If I don't cross anything out, I can't end up with a vertical or removable discontinuity. Is everybody okay with that? What do I have to do to find the x-intercepts? Who remembers how to do that? It's going to be a long test here, guys. If we can't remember any of these things, how do I find an x-intercept? When is a fraction equal to 0? When 0 is the numerator. So what are we going to do here? Set the numerator equal to 0. Okay. How do we find the y-intercepts? Well, what x-coordinate does something have to have if it's on the y-axis? 0, right? So what are you going to plug in for x? 0. And then for the last one, to figure out these other types of asymptotes, we need to decide, there was 3 cases for this, right? What do we have to look at to decide which case we're in? The degrees, very good. What's the degree for the numerator? And the degree for the denominator? 2. That was case 1, which is always y equals 0. Okay, so that's a review of things we've done up to this point. What we'll do now is we're going to start graphing this. So I like to start by drawing in my vertical asymptotes. So here at -2. Here again at +2. I have an x-intercept at 1, 0. I have a y-intercept at 0, 1/4. And I have a horizontal asymptote or end behavior here at y equals 0. Is everybody okay with this? All right. So what I'm going to be interested in now is I want to find out, as we approach this vertical asymptote, should my graph be going like this or like that? Everybody's okay with that? I'm going to use my calculator to do this numerically. So I'm going to start by typing in my function to my calculator. I use the fraction command here to make it look like a fraction. Highly recommended you do that, because if you try to do this without that fraction command, you need a whole bunch of parentheses to make that work. All right. What I'm going to do now is I'm going to take that fraction that I just typed in, and I'm going to plug in values for x that are less than -2, but are getting progressively closer to -2. So to do that, I'm going to use the vars command. I'm going to go to yvars, select function, and select y1. And we'll plug in, say, -2.1. And then we'll get a little bit closer and maybe plug in -2.01. And then maybe get a little bit closer and plug in -2.001. And what do you notice the output is happening each time? It's getting smaller, right? So which arrow should I have? Should it be going up or down? Down. So I know that I should be following my horizontal asymptote and then going down. Now we're going to look over here. I want to know, should the other side be pointing up or pointing down? To determine that, I'm going to do kind of the same thing. This time I'm going to pick values that are slightly bigger than -2, but getting progressively closer. So maybe I start with -1.9, and then we'll get a little bit closer, -1.99, and get a little bit closer. And what do I notice here? The values are getting bigger. So I want the one where the arrow's pointing up. Okay? So I'm going to have my arrow pointing up, and I'm going to go through my y-intercept and touch my x-intercept. And then I have to make the same decision here. Should my arrow be going up or down? How am I going to do that? I'm going to do it the exact same way that we did before. So here we're going to pick some values that are slightly less than 2 and just get progressively closer. And what am I noticing here? Each time the values are getting smaller, so the arrow I want should be pointing down. And then my last piece is going to either look like this or look like this. Again, we just want to figure out, should be the one that's pointing up or pointing down. We're going to do this the exact same way. We're just going to pick some values that are slightly, or getting progressively, or that are bigger than 2, that are getting progressively closer to 2. So we got that. Got that. Got that. So we notice here they're getting bigger, so we want the arrow that's pointing up. So there's my graph. Let's do another. This is the only skill we're going to be doing today, is just examples of doing this graphing. Okay. So again, we're going to start with our list. So let's do the vertical asymptotes and removal of discontinuities first. To do this, I have to factor. So 2 minus x, does that factor? No, because it's a linear term already, and the leading coefficient is 1, so I know that can't factor. And, well, 1 or -1, actually. And the denominator is x plus 3. Does that factor? No. Okay. Well, no factoring that needs to be done here. That's always nice. So if it can't factor, can it reduce? So immediately I can tell there's no removal discontinuity. So to find my VA, I'm just going to take the denominator, set it equal to 0. Everybody's cool there? Let's do our x-intercept next. How do I find the x-intercept? I take my reduced numerator and set it equal to 0. So there's my x-intercept at 2, 0. Let's do our y-intercept next. How do I find that? Plug 0 for x. So my y-intercept is 0, 2/3. And then for these other asymptotes, the horizontal or slant asymptote, I need to look at the degrees. What are the degrees here? 1 and 1, right? What's the rule when the degrees are equal? We have a horizontal asymptote, and it's y equals the leading coefficient of the numerator, which is -1, over the leading coefficient of the denominator, which is 1. So we just have a horizontal asymptote then at y equals -1. Okay, we got everything we need. Let's start drawing our graph. Again, I'm going to start by drawing in my vertical asymptote first, and then my horizontal asymptote next. And then I have my x-intercept, my y-intercept, and I just need to know what's happening at this vertical asymptote, right? So should it be going down or should it be going up? You're welcome. Okay. So to do that, I'm just going to go ahead and type in my equation into my calculator. 2 minus x over x plus 3. Then we're going to do the y's that are a little bit less than -3. You're welcome, Giselle. But getting progressively closer. What do I notice here? They're getting smaller, so the arrow is pointing down. Then we'll look at the other side. And I can tell already they are getting bigger. Oh my goodness. Look what I did here, folks. Where did I plot my x-intercept at? -1, 0. Where should it be at? Ay, ay, ay. Okay. Anyways, so now I just got to go arrow pointing up, go through my other 2 intercepts, follow the other asymptote. We're done. How's this feeling? Not bad, right? How many examples do you suppose we're going to have? 3. Why do you suppose we have 3 examples? Because we want one of each of the weird cases that can happen. You got it. All right. So start the same way. So we want to start by looking for the removable discontinuities and vertical asymptotes. So we'll factor our thing. How does x squared minus 4x minus 5 factor? What two things multiply to give us negative 5, but add to give us negative 4? Oh, this is taking so long. Negative 5 and positive 1. Yeah. There's only two numbers that can multiply to give us 5 here. Of course. I notice nothing reduces. So I have no removable discontinuity possible. So I'll just set my denominator equal to 0 and get a vertical asymptote out of that. The x-intercepts will set the numerator equal to 0, the reduced numerator, I should say. Same as the numerator, though, since there is no reducing. So I have two solutions there. So I have the points 5, 0, and negative 1, 0. To find the y-intercepts, we're just going to plug 0 in for x. So I have 0, negative 2.5. And the last thing we have is the horizontal asymptote or slant asymptotes. To figure that out, what do we need to first look at? The degrees. What's the degree of the numerator? What's the degree of the denominator? Oh no, that's the polynomial division one. Do I have to use polynomial division in this case, or could I get away with synthetic division? Synthetic division is possible because the denominator is monic. It has degree 1 and leading coefficient 1. That's the case. We celebrate because it saves us a whole boatload of time and space on our paper. Does that all look okay so far? What's the only part I care about? That part, which is going to be my slant asymptote. Everybody so far so good? Okay. So we'll start by graphing my vertical asymptote. And then we plot our x-intercepts, 2, 3, 5. And then our y-intercept, negative 0, negative 2.5. And then how are we going to graph the line y equals x minus 6? Well, that's a line, right? So I'm just going to get 2 points on it. So I'm going to pick my x's. I can pick any x's I want. So I'm going to pick 0. And 0 minus 6 is negative 6. And I'm going to pick 6. And 6 minus 6 is 0. So those will be the two that I plot for that. See, that's 1, 2, 3, 4, 5, 6. Gonna have to extend this here a little bit. Okay. So there's my picture. So far, so good. Now, I can tell immediately what's happening to the right of my vertical asymptote because I have to pass through these points and follow that asymptote. And there's really no other way to connect those 3 points other than coming, from the top down to hit all that stuff. Well, that's lovely. Now all I have to do is check the stuff that's going on to the left of my vertical asymptote. So I'm going to pick some values that are, I got to type in my new equation, though. Almost forgot that. That would have been just tragic. Would have made no sense at all. The results that we had. Do that first. Getting in a hurry there, Mr. Kulik. I know. All right. So left of our asymptote, and then we'll get progressively closer. And I can see what's going on, right? What direction should I be heading? Down. So we must be following that asymptote and then heading down at the vertical. So there's my graph. Elise. Sure thing. So this is very much just like a continuation of what we've done the last couple of days. Should feel like a natural extension. You guys should now be able to do 13 to 24. And certainly should be able to do the entirety of the delta math at this point. We're stopping here. You should get some stuff out, work on your homework set or work on your delta math, whatever is, wherever you kind of left off at or wherever you'd like to start at is fine by me. Remember, the delta math is due Sunday. And then we're looking at like 1 through 13, I would say. Or I should say 1 through, well, let's say 1 through 16 should be the assignment that's due. Since we started 13 through 16 last time, I think, right? Yeah. We'll finish those up. We'll count those as part of this problem set. Everything else will be on the next one. Fair? Fair enough? Reasonable? Okay. I'm going to stop talking and let you guys get crack-a-lackin'. If you have questions on anything or you're stuck or you need some help with your calculator or whatever, feel free to come up and talk to me. I'm happy to see you. Otherwise, stay busy, guys. Get some work done so you have nothing to take home. Yes, sir. Absolutely.